Hi, here we have a question from Leningrad Mathematical Olympiad year 1961. This question is for ninth grade students. The question is to prove that all numbers in these forms can be written as complete squares. Maybe I spend around 5 to 10 minutes to find the solution and then come back and see the solution. Alright, so here are our numbers. The first thing that comes into mind is that maybe we should write this number as a square of another number. Of course, this number is small, so even if you are not a human calculator, you can easily calculate the square root of these. We know that 30 power 2 is 900, 40 power 2 is 1600, so this number is for sure between 30 to 40, and because the last digit is 6, it means it should be either 34 or 36, and then you multiply, you see that 1156 is 34 power 2. Even this number, we can actually calculate the square root without calculators. Of course, these questions, you are not permitted to use calculators. So for example, what we can say is that this number is certainly less than this number. So this number is actually the same number as we have here. I put 2 more 0 here, and this is equal to 340 power 2. And because the third digit is 5 here, this is 1, so certainly this is larger. So this number is less than 340 power 2. And then if we just eliminate these two digits, putting 0 there, so this is 100 times 1115, and this one is certainly larger than 33, so this whole number is larger than 330 power 2. And for the same reason, because the last digit is 6, we can conclude that this number must be 334 or 336, and then if you do multiplication, you can see that this number is 334 power 2. Anyway, we can find that this one is 34 power 2 and this one is 334 power 2. So obviously you see the pattern already. Probably this one will be 3334 power 2 and so on. Okay, so let us start and do something different. So we have this number. We can write it as 1100 plus 56, but 56 is 55 plus 1 and 55 is 11 times 5. So we can write it like this. And then the next number, we can take 3, 1 and then 3, 0, 555 plus 1, and that is 5 times 111 plus 1. And the same way for the next one, we can write it 4, 1 and 4, 0. Here we have 5, 5, 5, 6, which we can write it 5, 5, 5, 5 plus 1. And that one we can factorize 5. So actually all these numbers can be written in this structure. Obviously, we can also write these numbers in other ways. For example, this number can be written as 1, 1, 1 plus 45, which is 4 times 11 plus 1. Same way for the next one, all 1 plus 111 times 4 plus 1, and so on. After a little bit of investigation, you notice that when you write in this format, this is better and it leads you to the solution easier. Notice that we had shown already 1156 is 34 power 2, and this 34 is obviously either 3 times 10 plus 4 power 2, or maybe is 3 times 11 plus 1 power 2. And then after a little bit of manipulation between these two choices, you also realize that this choice will lead you to the solution in a better way. So the number can be written as 3 times 11 plus 1 power 2. And we see also here we have a lot of 11s. And for the next one, of course, 111s and so on. So we must be able to write this number in such a way that we produce 3 times 11 plus 1. Okay, so let's see what we can do. We have 1100 plus 11 times 5 plus 1. And this one, obviously, we can factorize 11. 11 times 100 plus 11 times 5 plus 1. Now, how can we create 3 times 11 power 2? 3 times 11 power 2 is actually 9 times 11 power 2. Okay, so if I take one of those 11 and 9, that is 99. So maybe I should, instead of 100, we should write 99 plus 1. And this one is 11 times 5. And now this 11 multiply 99. plus another 11 plus 511. So actually this one is equal to 11 times 99 plus 11 times 6. One of these goes and add to this one plus 1. And this one obviously is a square. That is 3 times 11 power 2 plus 11 times 6 plus 1. And this can be written as 3 times 11 plus 1 power 2. Okay, so we managed to write the first one in this format. The next number, we can also use the same strategy. So 111 times 1000 plus 111 times 5 plus 1. And again, we can write this one as 999 plus 1. That plus 1 comes to here. And obviously, this is 3 times 111 plus 1 power 2. So in general, basically, we can say that if we have n1, n minus 1, 5, and 1, 6, this is equal to 3 times n1 plus 1 power 2. So all of these numbers can be written as a complete square. All right, so let's see what we have learned through this exercise. Evaluate the first few terms and try to find an initial guess about the pattern. You remember that we had 34 and we said 34 is 3 times 11 plus 1. That already helped us a lot to figure out the actual pattern, which then we wrote 100 as 99 plus 1 and so on. The second point is obviously to rewrite the numbers in a different form so that it produces more information for you. So for example, we wrote 100 as 99 plus 1, and after we multiplied, we managed to create the square. All right, so this is the end of the video. See you next time. Bye.